All right, good afternoon, good morning. I know we got some West Coasters out there on the call, so appreciate you joining us today. This is Hunter Two-Wire Fundamentals. This is part one of a three-part series that we're going to be hosting. I am Reid Garner. I'm the Specification Sales Manager for the Southeast region, and I have on the call with me Mr. Dirk Hessman, who is our Field Service Manager for the Southeast. So Dirk's kind of our technical guru, and we refer to him a lot, and he helps us out. So I've got him on the call as well. So like I said, thanks for joining us, everybody. We're going to get going here. We want to be respectful of your time. So most of these webinars that we've been doing have been in the neighborhood of about 30 minutes. This one is probably going to go a little longer than that, just because there's a lot of material to cover, but we'll try to be respectful of your time. So what we're going to do is I'll go through the presentation, and let's go over a little bit of housekeeping here. So like I said, this is part one of a three-part series. So not next week, but the week after is part two. We're actually taking a week off. Part two, we're going to talk about design considerations, best installation practices, and basic troubleshooting. Then the week after, we'll get into some advanced troubleshooting. So like I said, with the housekeeping, if you've got questions, there's a question box right there on the software. So if you want to enter that question at any time during this presentation, Dirk's going to be on the computer. If he can answer it quickly, he's going to go ahead and answer you through the chat box. If we don't get to it through the course of the presentation, then at the end, I'll go over some of the questions, let Dirk answer some of the questions. So if you want to hang out, hear all the questions, great. If you've got other stuff to do and you want to take off, that's fine. So this webinar will be recorded. You'll get an email probably about an hour after this ends, and it'll have a link to the recording so you can go back and refer to it. And we'll also have it on our go-to stage, which is basically like a YouTube account. So you can check it out there as well. So without further ado, let's talk about what are we here to talk about today. So I'm going to start off talking about an electrical refresher, basically some basic electrical principles that I think are very important to know when we're talking about two-wire irrigation control. Bear with me, it may sound and it may give you flashbacks to high school physics, but I think number one, it'll be interesting to you, and number two, it'll really give you perspective on how this stuff all works, especially if you're going to stick around for parts 2 and 3 here in a couple weeks. The troubleshooting, it's really critical to know these electrical concepts and really understand them. After that, we're going to talk about kind of the science of two-wire, how it works, what it does. And then we're going to get into a brief overview of our Hunter two-wire products. We basically have two different two-wire products. We have the ACC2 controller and the ICD family of decoders. That's kind of our Cadillac high-end commercial controller. Then we've also got a new easy decoder system, which is sort of our mid-range commercial, high-end residential two-wire controller. Pretty much everything that I'm going to talk about science-wise is going to be in the perspective of the ACC2 and the ICD. Once I get to talk about the easy decoders, you'll understand that it's kind of a totally different beast than the traditional two-wire that the ACC2 and the ICD is. So just keep that in mind, and we call it easy for a reason. You'll understand that as we go forward. So without further ado, let's get into it. So conventionally wired irrigation, you'll hear me say that word conventional, and basically what that means is it's a traditional irrigation controller that has one dedicated wire for every valve and then one common wire that completes the circuit back to the clock that basically ties all of the valves together. So if you've got 100 valves in the ground, you're going to have at a minimum 101 wires in the ground. So you've got 100 wires for your stations, and then one common wire at a minimum. Sometimes you can have more than one common wire. So that is what I mean when I talk about conventionally wired irrigation. So what we're here to talk about is two-wire. So you'll hear me kind of say the terms two-wire, decoder interchangeably. It means the same thing. Two-wire refers to the two wires that the system operates on. Decoder refers to this guy here. So it really means the same thing if I say decoder system, or if you hear somebody say 2-wire, same thing. It's like, just a different term for the same thing. So decoder technology allows us to run all the valves over a single pair of wires. So that pair, 2 wires, hence the name 2-wire. So you see in this diagram here, you've got the 2-wire path, you've got a decoder at every valve, and that's basically the concept, the basic concept of a 2-wire irrigation system. Not only do they share the same wire, but we send a communication signal that tells whatever station 5 in this case, to turn on, and the other decoders know that they don't need to turn on at that point. We'll talk a little bit more about how that works here in just a minute. So why do we want to go with 2-wire? So what are the advantages? So basically, one of the main advantages is that you save copper wire. So copper is a expensive non-renewable resource. Typically the break-even point, so decoders cost money, right? These aren't free. So you have to have a break-even point when the cost of the decoders becomes less than what the cost of copper wire would be with a conventional system. Typically, that point is around 25 to 30 zones with an ACC2 ICD type system. When we talk about the easy decoder at the very end, that break-even point is even lower because the easy decoder is a much more economical, much simpler for simple installation. So that brings that down to about 15 to 18 zones as your break-even point. Another advantage of 2-wire is that you can run more stations over longer distances. With the ACC2, you can go a single wire path up to 15,000 feet away from the controller. Probably instances are rare where you'd have to do that, but on like a highway or an entrance to an HOA or a multi-family development that has shared irrigation, it really gives you some flexibility to go long distances away from the controller. You can also run more solenoids at one time. So the decoders use a little bit less power than a conventional system. So you're going to be able to, instead of running 3 or 4 solenoids at the same time or stations at the same time, you can run with ACC2, you can actually run up to 30. So a lot of flexibility in programming there. Really, really key advantage of 2-wire is the flexibility. So you can add in stations after the fact. So this is great product for phased installation. So if you've got a housing development that, let's say phase 1 is 30 houses and it's going in next month, but then next year you're going to have another 100 houses. So with a conventional irrigation system, if you had the clock at the entrance and you ran all your station wires to every valve, if you wanted to expand out, what would you have to do? You'd have to run new wire all the way back to the clock. With a 2-wire system, you simply tie onto the 2-wire path where you left off, keep on going. So it's great for phased projects, very flexible. For the installers out there, for the contractors out there, really easy to pull 2 wires instead of a big chunk of 30, 14 gauge wires. I'm a contractor in a former life, so I've been there, and I know that pulling 2 wires through a bunch of sleeves is a lot easier. Troubleshooting, a lot of guys will tell you that they hate troubleshooting 2-wire, but if you know what you're doing, way easier because you only got 2 wires to solve. And then lightning resistance, you've got fewer, less copper in the ground, you're less susceptible to lightning if you're grounded properly. We're going to talk a lot more about grounding in part 2 of this series, but grounding is very crucial when it comes to 2-wire. All right, conventional versus 2-wire. I love to show this slide. On the left, you've got a conventional wired system. On the right, you got a 2-wire system. Now, if we were in a live classroom, I'd say, how many people have seen a controller that's conventionally wired that neat? Raise your hand. Nobody will raise their hand. I've never seen one. I think this is probably our demo at that we use for trade shows. Very clean, very pretty. I've hardly ever seen one like that. Normally, this is what you see. You see a bird's nest of wires. It's all in there. Sometimes there's ants, sometimes there's hornets, sometimes there's spiders. So this is what you see. So on the left side, you've got conventional. On the right side, over a single pair of 2 wires, you've got all those same stations. So it just illustrates here the advantages of 2-wire. So let's get into that high school physics that I talked about. So a little background about me. I've been in the irrigation business for, it's about 2006, somewhere in there. Spent time as a contractor, time in sales for a manufacturer. Then I left the irrigation business in 2015 and I went to work for a manufacturer of electric motors. Was there for 2 years, and you know what they say, irrigation's like the mafia. Once you get in, you never get out. So I came back to Hunter in 2017. But I tell you this because that 2-year period that I did in the electrical industry, I had to learn a lot. I was an irrigation guy, and I knew the basics about electricity, but I really had to teach myself a lot in a short period of time. So it helped me as an irrigation guy to think of electricity in terms of water, because it was something that I could relate to. So basically, in its simplest terms, water flows through a pipe, and electricity is the flow of electrons from atom to atom in a conductor. If you think about, you've got a copper wire, you've got the atoms just stacked up next to each other. It's not really that simple, but just imagine you've got your outer electrons that are basically just flowing from atom to atom to atom. So that's what electricity is. It's the flow of atoms. So if you make that comparison to water, it really clicks, and that's what made it click for me. Talk about some units of measure when it comes to electricity. I love this chart here because it compares electricity to water. So our unit of measurement for flow, water, we talk about GPM, gallons per minute, right? Electricity is what we call the ampere or the amp. You'll see that abbreviated as A for amp, or sometimes you'll see it as I, that stands for intensity. Pressure, a unit of pressure. With water, we think of what? PSI, pounds per square inch. Electricity, we call that volts. You'll see that abbreviated as V, or sometimes E. That stands for electromotive force, but that's a volt. Resistance, water, that's friction loss. Electricity, that's what we call the ohm, and that's abbreviated with the Greek symbol omega. So one of the things, voltage was always one of those things that was a hard concept for me to grasp. And because you always hear that people talk, well, it's not the volts that kills you, it's the amp. Well, yeah, that's true. You have to have flow through your body for you to be electrocuted. But what voltage is basically the way that it was explained to me, and it finally clicked, was if you can imagine those atoms. If we go back to this slide here, see those electrons flowing from atom to atom. Voltage is the pressure, it's the potential. So if you imagine a spring between every electron, the higher the voltage, the stronger that spring is. So when that gate opens, when that circuit is completed, it's going to take off. So that's how voltage was explained to me, and that's when it really clicked. So you can kind of see how voltage and pressure are related, voltage and flow or amps are related. So keep thinking and making that connection of electricity to water will really go far for you. Talk about Ohm's law. So Ohm's law states that volts equals amps times resistance, or V equals IR in its simplest form. It takes 1 volt to push 1 amp of current through a conductor with 1 ohm of resistance. The greater the resistance, the more voltage required to move the same amount of current. So it's just like in a pipe with water. The higher the friction loss, the more pressure it takes to push the same amount of flow. So I love this little cartoon that we got here of these little guys here. So that just really illustrates that right here. Direct current. So this is a type of current where the flow of electrons is unidirectional, means that the electrons flow in one direction only. An example of this is batteries. Thomas Edison proposed powering the country with low voltage DC back when electricity was first being brought out to the mainstream. That's opposed to alternating current, which the flow of electrons is bidirectional, meaning they reverse flow at regular intervals. It's much more economical to send over long distances because it can be stepped up and down or transformed, and that helps you to be able to send it over long distances at a high voltage, transform it down at a low voltage to be able to be used. So George Westinghouse and Nikola Tesla were proponents of AC power back in the day. This is a comparison of the waveforms of direct current and alternating current. So on your y-axis, you've got voltage. On your x-axis, you've got time. So you look at this as the voltage on an alternating current, it goes up, it raises up, and it goes back down negative, and it comes back to zero. So direct current stays the same voltage as it goes forward through time. At the World Fair in 1904, the Edison Company, Thomas Edison, submitted a bid of over $1 per lamp to light the fair with DC power. George Westinghouse Company submitted a bid at 25 cents per lamp, and pretty much from then on, the argument was settled. That's why we use AC today and not DC. Here's another just good illustration of the difference between direct current and alternating current. So you've got a battery, you've got the electrons flowing in one direction. AC, you've got an alternator or a generator here, and it's the electrons are moving back and forth. They're reversing at a certain time period over a certain interval. So what does all that stuff that I just bored you with have to do with what we're talking about right now, and that's two-wire irrigation? So here, a conventionally wired controller, like we talked about, one that has a wire for every valve, takes in 120 volts AC at 60 hertz, transforms it to 24 to 26 volts AC at 60 hertz. So that's what those solenoids on the valves operate off of. This is opposed to a two-wire or a decoder controller that takes in 120 volts AC at 60 hertz, and then it puts out a signal that's 30 to 35 volts, and it's pulsing. And what pulsing means is it goes from positive to negative, and it does that 1 to 2 hertz. We'll talk about what hertz is here in just a couple of slides. So a nice, pretty conventionally wired system, a nice, pretty sine wave. You've got, just like we looked at before, you've got your sine wave where it jumps up to 26 volts positive, comes down to 26 volts negative, and it comes back to zero. Now it does that 60 times per second, or 60 hertz. So a hertz is the equivalent to a cycle per second. So if you think about it, if wherever you are right now, look at a light. So if you're in an office, look up and look at a light. That light's actually flickering on and off 60 times in a second because the voltage is going positive, it's going to zero, it's going negative, back to zero. So even though it's flickering, it's so fast your eye can't pick up on it. It's a little trivia that you can tell the kids tonight over dinner. But this is a pretty 24 volt AC sine wave. Now, in a two-wire controller, actually, let me back up. So this is what we call an oscilloscope. It's basically a device that reads what a electrical wave looks like. So this is what a nice, pretty 24 volt sine wave looks like in an oscilloscope. Now, comparing that to a two-wire controller, you've got what we call a square wave. So you've got 38 volts positive that it stays at for a certain period of time, and then you've got 38 volts negative that it stays at for a certain period of time. So it's sort of, it reverses itself like AC power, but it stays at the same voltage. It doesn't have this constant drop like a sine wave. So it stays at the same voltage for a certain period of time. And it rotates like that only 1 to 2 times per second, so 1 to 2 hertz. So this is what that looks like in an oscilloscope. So you see it's positive for a certain period of time, then it immediately drops to negative, positive. So you can see how it really, it has properties of both AC and DC power. Now, why is that important in a two-wire? That's because we send data in between those pulses to tell certain stations to turn on. We send data that gives flow data back to the controller. We send data that tells if a rain sensor is coming on and off. So embedded within those pulses is data. Real important to understand that concept. So with a conventional 24 volt AC controller system, Like we talked about, I'm going to reiterate this. You get 24 volts at 60 hertz. The flow in amps is 250 milliamps or 0.25 amps. This is a conventional system. Just like we talked about, you've got a wire for every valve. So you've got your controller, a dedicated wire for every valve, and then that black wire is a common wire. This is opposed to the decoder system. So you've got your 2-wire over here on the left side. Like I talked about, it's pulsing at a roughly 35 volts, 1 to 2 hertz. And then the signal that actually goes from the decoder to the valve solenoid is a little bit lower, but it's turning faster. So it's almost like we're tricking the decoder or tricking the solenoid into coming on. So it's actually buzzing at 500 hertz. One thing to keep in mind is that with a 2-wire controller, the 2-wire path is constantly hot and pulsing. It's not like a conventional system that only turns on when the system is running. With a 2-wire system, even when nothing's running, it's constantly pulsing and it's constantly sending data back and forth. So this is another illustration of a 2-wire decoder system. We've got our controller, we've got our valves. Next, we have our wire paths, our 2-wire paths. So each one of these colors, blue, gold, and purple, represent an individual 2-wire path, so a set of 2 wires. So we'll talk about how you can have multiple 2-wire paths out of the same controller, but these represent a single 2-wire path. So you've got your 2-wire paths, and then you've got the decoder spliced in. So here's the decoder here, and I'm going to show you that, if I can get this tie off of it, that you've got on one side, you've got your leads, your red and your blue leads from the wire path right here. If you guys can see that. Then on the other side, you've got your black leads that go out to your solenoid. So this goes into your solenoid. So as you can see in this diagram here, you've got your 2-wire leads tied into the 2-wire path, your black leads go out to the solenoid. Some decoders are going to be grounded on some points on the 2-wire path. Like I said, we're going to talk a lot more about grounding in part 2 of this, but you do have to ground your 2-wire path. And remember, like I talked about, it's constantly hot and pulsing. And then where the magic happens is the data that gets sent back and forth. If you saw that little squiggly line, that's where the magic happens. So we've talked about what 2-wire is, how it works, kind of the concepts behind it. Now let's talk about Hunter's 2-wire solutions, what we can offer. So really two different products here. We've got the ACC2, which is our advanced commercial controller, high-end Cadillac for, we can pretty much do anything you need it to do. It's a 2017 IA New Product of the Year. Works with the ICD family of decoders, these guys here. Then we have our ICC2 and our HCC. So the ICC2 is our mid-range controller. The HCC, which is the one with the touchscreen, is basically the same controller that works on the HydroWise central control platform. That product, these 2 controllers work with the Easy Decoder system, which we'll talk about at the very end, because like its name implies, it's very easy. It doesn't take a whole lot of time to explain it. So pretty much everything we're going to talk about here is in terms of the ACC2 controller. I could spend 2 hours talking about everything that the ACC2 can do. It's a very powerful controller, but we don't need to know that for the purposes of this presentation. We need to know what it can do as far as 2-wire goes. I am going to talk just for a minute about the controller though. So first thing you'll notice is that it looks different than any other controller that you've probably ever seen. We took the inspiration from this from our Luxor lighting controllers. I'll tell you that once I got used to this, when I have to go back and do a regular dial controller, I get a little frustrated because this is so easy and so intuitive. It's compatible with the ICD decoders, like I said, and then it can control up to 225 decoder stations, so large projects. It's built for installation and service. These are just a few little small things that the contractors on this call are really going to appreciate. It's got a reversible face pack. So when you open it up and you're looking inside the chassis, you can reverse the face pack so you're not constantly opening the door like this back and forth. Great feature there. It automatically goes into diagnostic mode when you do that. You can still operate all the features when it's backwards, but it's just nice to be able to see faceplate on one side, chassis wiring on the other, and be able to not have to be flipping back and forth. The wall bracket that you mount it with is so easy. This thing, the metal version of it, weighs 30 pounds, but I can hang it by myself because you take this little metal piece, you can see it on the picture here, you hang that piece on the wall, then the controller, you literally pick it up and set it up on those hooks, run one screw in the bottom to keep it from moving, that's it. You can hang this 30-pound controller in 5 minutes. Really, really simple. And another cool feature that's one of those, geez, why didn't we do this 20 years ago, is an on-off switch on the transformer. So if you've got to service it, instead of having to go find the breaker or pull the pigtail out of the plug, all you gotta do is flip that little switch. Great little feature there. Features at a glance, like I said, I'm trying to give you a 35,000 foot overview of the ACC2 in one slide, which I could talk for a long time about this controller, but the gist of it, what you need to know is that it's 225 stations, 32 programs, 10 start times. So it's going to be able to program any sort of irrigation, automatic irrigation program that you've got. We'll operate 6 flow sensors and 6 master valves. So what that means is you can control up to 6 separate points of connection or flow zones. Has some really, really powerful flow features, flow management, which basically means it will learn the flow of each individual station. And then if you need to set a flow target, so you see down in this bottom screen here, if you know you have a 2-inch water main and you want to keep it within IA specs for velocity, which is 5 feet per second, you know it's going to need to be 55 gallons a minute. So you can set that the max flow that will never ever exceed is 55 gallons a minute. Then what it will do is it will go out and find zones to make up 55 gallons a minute. When one zone is done irrigating, it'll find something else that's close to make that 55 up. So it will run your automatic irrigation program as close as possible to that 55 gallons per minute all night long. So what that does is it does 2 things. Is it keeps you within your safe flow, number 1. Number 2, it runs your irrigation in the shortest window possible. So it does all that work for you. So that's a really, really powerful feature for large properties. Flow monitoring is basically your overage and underage alarms. You can set that percentage, 125%. I want to know something's wrong and something's up because there's probably a break somewhere or a couple broken heads. Conditional response, this is probably my favorite feature of the controller. You can basically program in if-then statements. So you can say, if sensor 1 is closed, then start this program. You can do a lot of different things. The example we use a lot is if you've got 2 water sources, let's say you've got a lake, you've got a potable source as a backup. You have a float switch on the lake. So if that thing gets pumped dry, you can say, if this sensor closes, meaning it's dry, then open up this master valve, which is your potable backup. It'll actually make that change in the middle of an irrigation cycle and won't miss a beat. So that's a cool tool. And then it is cloud central control capable with our Centralis software. Has some great decoder diagnostic tools. You can see a live current display, decoder inventory. This is a great feature. If you've got a really large property, it'll take an inventory of every decoder that's out there on the system, how well it's communicating back to the controller, and then you can take a record of that, save it to the SD card that's in the back of the faceplate. The next year when you go do your spring startup, you can do another one and you can compare. You can say, okay, I've got one station that's not responding. Let me go check that one out. A lot of other diagnostic features. We'll dive more into these in parts 2 and 3, but this is kind of the gist of what this controller can do. The ACC2 works with the ICD decoder models. So right here, you see all the models. You've got a single station decoder, a 2-station decoder, 4-station decoder, 6-station decoder, then a sensor decoder. One thing that I really, really want to drive home here is that, and this is true of all Hunter decoders, is that Hunter decoders are programmed with the actual station number. So this is a single station ICD decoder right here. If I want to program this as station 17, I program this as station 17. We'll talk about how to do that in just a second. But this decoder is now station 17 until the end of time, unless it's told different. If the clock goes out and you have to replace the clock, doesn't matter. This is always going to be station 17. So when you put the new clock, it's going to run station 17. This decoder is still going to respond to it. There's some competitors on the market out there that you have to enter a serial number into the clock, which this, I don't know if you see this does have a serial number, but you have to go into the clock and say, okay, station 4 is decoder 178-75271. Okay, that's fine, but if the clock ever goes bad and you have to put a new clock on, guess what you have to do? You've got to enter all those serial numbers again. So really want to drive home the point that Hunter decoders are programmed by station number. You can do that directly from the clock. There's a programming port. You basically take your leads, put it in the port, say, I want to program this. You see this top screen here as station 5, hit program, boom, it's done. Or we have this little magic wand here that we call our ICD handheld programmer. You can do this through, I call it through osmosis, but it's actually through magnetic induction. But you can program, if this is already installed, if the decoder is already installed on the 2-wire path, as long as it's getting power from the clock, you can program this or reprogram it in the field with this guy here without breaking any wire connectors. Really, really powerful tool. So you can do that. Some guys that install these will actually just go ahead and install every decoder without being programmed, and then they'll go to valve box to valve box, taking this guy and say, okay, this is 1, this is 2, this is 3. I would recommend doing it from the clock beforehand, but I've known guys to do that. So that's a really powerful tool that is unique to Hunter 2-wire. The ICD decoder family, like we talked about, you can get a 1-station, 2-station, 4-station, 6-station decoder, plus a sensor decoder. So the station decoders will operate a regular valve. So if it's a 6-station decoder, you could theoretically run 6 valves, have different outputs. So you could have stations 1, 2, 3, 4, 5, and 6. There's 6 sets of leads coming off that decoder. One thing about the ICD is that they are 2-way communication. So the clock sends out a signal. It says station 17, I want you to turn on. Station 17 turns on and it sends a signal back that says, hey, everything's okay. I'm operating just like normal. If this decoder happens to be bad, if it got hit by lightning, it will not obviously send that signal back. The clock's going to know what's up, that something's up, and it's gonna throw a fault. So it'll make a record of that. So that will be logged in the controller log. So 2-way communication, want to make sure that everybody's on board with that. One thing that ICD decoders do have is they have a built-in surge suppression. So we don't require extra surge modules or a dedicated surge module. Every ICD comes with this blank copper ground lead here. So when we talk about grounding next week or in 2 weeks, we'll talk about how to ground this off of the decoder. You don't have to buy any extra parts. You don't have to buy a surge mod. Our general rule is ground every 12th decoder or every 1,000 feet or more frequently. If I got anybody from Florida on this call, then I'd probably suggest doing it a little bit more, even though here in Georgia where I am, we get a lot of lightning storms too. But we'll talk a lot more about grounding and what the requirements are and how to do it properly in the next session. Talked about the ICD HP. I'll just go over that one more time, but it's basically a wireless programmer. There are a lot of diagnostics that you can do with this. Reduces installation time, simplifies diagnostics, and you can test sensors. You can activate stations with it. You can test voltage on the 2-wire path. A lot of really cool things that it can do. So if you do a lot of 2-wire, Hunter 2-wire, it's really an invaluable tool that you can have. The connection's wireless. Like I said, I call it osmosis. It's like when you were in school and you wish you could just fall asleep on a book and everything in the book would automatically download into your brain. Never worked that way for me anyway. But that's kind of how it works. And you can do that out in the field after it's already installed. So you can go out, you can troubleshoot decoders, you can reprogram decoders, you can program them from the first time, you can check voltage, you can do a lot of cool things out in the field with this tool here. All right, so everything we just talked about is in terms of the ACC2 and what I call old school traditional 2-wire, which is great, has its place because it can do a lot of powerful things, a lot of communication going on there. But about a year ago, Hunter released what we call the Easy Decoder system. And the best way I can explain it is that it's a decoder system that plays by the rules of a conventionally wired system. And you'll see what I mean here in just a minute. But the two controllers that this system works with is the ICC2, which you see at the top, and the HCC at the bottom. So the ICC2 is compatible with our Centralis, which is the same system that the ACC2 works on. The HCC works with our HydroWise platform. They both use the same Easy Decoder system. So it's new decoder technology. It works on 24-volt AC, 60 hertz. So everything that we just talked about the 35-volt pulsing, this is more similar to, and this is the decoder here. You see this guy here, this is the Easy Decoder. Works more like a conventionally wired system. Drawback to that is that there's no communication going on. It's basically just a simple on-off, on-off. You can't do sensor decoders, but it is an economical 2-wire solution when simplicity is needed. The typical break-even point is around 15, 18 zones. And like I said, it's sort of a 2-wire system that plays by conventional system rules. So, when would you use this? I'm kind of getting ahead of myself. I did want to just make sure. So the way that this works is you put this decoder module you see on this inside of this ICC2, you've got the Easy Decoder module. So you just put that in there, replacing a conventional module, and it converts it over to the Easy Decoder system. So you can run a combination of conventional stations and 2-wire stations with the EasyDM, but it's a 54 station max in any combination. It doesn't unlock a magic key where you can get more stations. It's 54 stations max, but it's very cost effective. And like we said, here I put 12 to 15, but it's more about 15 to 18. But that's just material costs. If you factor in the labor costs of only having to pull 2 wires versus a big chunk, I think that break-even point comes down. So that's probably what we meant here by that 12 to 15. So when would you use the ACC2 ICD versus the EasyDS? So, it really depends on what the project's calling for. The EasyDS, I won't say a drawback, but since it's 24-volt AC, it is bound by the physical laws of 24-volt AC power. So what that means is that the wire path distance can't be nearly as far. It's only about 3,400 feet, and that's with 12-gauge wire. Like I said, it's one-way communication, and it's really not even communication. It's basically just an on-off. You can't do sensor decoders. Max station count's 54. You get all the features of an HCC or ICC2, and it is the lowest cost. So when cost is a consideration, when you don't need sensors over the 2-wire path, when you've got less than 54 zones, this is your guy right here. When you have those projects that require that extra level of monitoring, you need 2-way communication between the decoder and the clock. You got to go a long way, up to 1,500 feet with the ICD. You got 225 stations, and you need all those really powerful flow features of the ACC2. That's when you want to go with our ICD ACC2 type setups. Highest performance, it's the Cadillac. It's going to do pretty much anything you need it to do, and you're going to be really happy with what you get. So this just kind of gives you a comparison of what what each system does, what their applications are. So, you know, I would encourage you to really look at your projects and understand what its requirements are, and then make an educated decision on which way to go based on what you need. So with that being said, this sort of brings to a close part one. If I can, I'll do like the like when you watch a TV show on Netflix, it says next week on whatever show you're watching. So I'll give you something to look forward to. So part two on May 14th, we're going to talk about designing a two-wire system. What are some of the things that you need to think about, especially if I've got some landscape architects on the call here? This is going to be the call that, you know, I think you'll get a lot out of, because you will understand like how to lay out wire runs. We'll talk about things of that nature. I'm going to spend a lot of time talking about grounding, how to ground properly a two-wire system, how to plan the system, and we'll talk about best installation practices, and then we'll dive a little bit more into programming decoders, either with the ICD-HP or with the doing it from the faceplate. Part three on the 21st of May, we're going to really dive into some troubleshooting stuff. I got some contractors out there on the call that are really wanting to brush up on your troubleshooting skills. This is when I'm going to really lean on Dirk for his expertise, and he's going to be kind of running point on that one, talking about, you know, what are some of the things he looks for when he's going to a system and he's troubleshooting it, faults and alarms, how to isolate them, wire diagnostics, either using the ICD-HP or using a clamp ammeter. So we'll take a deep dive into some real advanced troubleshooting concepts there. So that's all for today. We're about 43 minutes in, so that's perfect. That's what I was shooting for. Really want to thank everybody for taking the time to spend with us today. Hope you learned something, and I hope that it was good enough for you to come back for parts 2 and 3. So I'm gonna check these questions here. And we've got one question, and if Dirk's on, he can pop in, but I know the answer to this. So Jay is asking, can the ICD-HP program the easy decoders too? The answer to that is no, it cannot, because it's they basically speak a different language. But hang tight, give us a little bit of time. We are in development of a similar device for the easy decoder, but that won't work with ICDs, and then the ICD-HP won't work with the easy decoder, just because they speak a different language. Is that right, Dirk? Is that?
Yeah, that's correct. One big difference, and you've kind of touched on, is the easy decoder is 24 volt AC, and when nothing is turned on, there's no line current down there. So the ICD-HP is designed for the DC volt at this moment, and it's got to be powered up to be able to use that inductive. So with no power there, it's not able to read an easy decoder. So at the moment, it does not work, to answer your question, but we are currently trying to develop one. Yes.
Good deal. Well, that looks like that's the only question. Let me check the chat box. Sometimes people will send, nope, don't see an error. So, all right, last call for questions, but if nobody's got any questions, really appreciate y'all taking the time to spend with us today. Thanks, Dirk, for being on the call and being my technical backup.
Y'all made it easy.
And we'll see you guys in 2 weeks for part 2. So thanks. Enjoy the rest of your day.